Coffee husks, so question 9 now. Coffee husks are shown in the photograph are a waste product of coffee plantations. Composting has been suggested as an environmentally friendly way of decomposing these coffee husks. The effect of adding cow dung to coffee husks before they are composted has been investigated. The table shows the percentage of organic carbon and nitrogen in 2 compost heaps at the start of composting after 90 days. So it kind of looks like a cross between topic 5 and topic 6, because in topic 6 we had a little bit of decomposition stuff. Okay, all right. So again, it's a comment question. So I'm going to go with the things I notice. As a result of this, you can see I've already done some work here. But basically what I was doing is looking to see if using the numbers that they've given me, if I can work out what the changes are. Because it says comment on the effect of adding cow dung to composting coffee husks. So the effect is basically what happens when we go from husks alone to so the change over the time. So the effect. So what's the effect on the change? So this is the change right here. So the organic carbon, without any husks, without any cow dung added, it goes from 54 to 41, and that's the change of 23. Now, so that's normal, that's our control. But then when the husks are added, we want to see what the effect of that is. So it goes from 48 to 35, which is a change of 26. So it looks to me like adding the cow dung increases the amount of organic carbon that's a decrease, isn't it? Yeah, so it decreases the amount of carbon that is in the compost heap, because it decreases by more. Okay, and nitrogen it's the opposite. So nitrogen increases over that time, goes from 1.8 to 2.31, 2.76 to 3.19. But the effect of adding the husks is that there is a smaller increase. Okay, so it's for 3 marks, and again I'm going with what I noticed. So adding dung slightly decreases the organic carbon percentage in the husks after 90 days. It increases the nitrogen percentage, and I could compare the percentage, because the effect on carbon is smaller than the effect on nitrogen. So the effect on nitrogen is bigger than the effect on organic carbon. Okay, so I've tried to go for 3 marks there, but I'm not super confident with that one. Right, the changes in the compost heaps are due to the activity of decomposers and other organisms. Devise an investigation to determine the effect of the carbon to nitrogen ratio on the succession of species in these compost heaps. Okay, so because it's a practical question, what I'm thinking about first is what am I changing? What am I investigating? In other words, how am I measuring that? And what am I keeping the same in order to make a valid experiment? So I've gone with setting up compost heaps with different starting compositions of coffee husks, because changing the amount of coffee husks could affect the carbon nitrogen ratio. So I've got different heaps with different starting amounts of coffee husks added, cow dung added, and then I'm going to take a sample from each compost heap at regular intervals, let's say 10 days for 90 days. And then, because succession should involve changes in species over time, so what I'm going to measure is I'm going to measure for each sample, I'm going to determine the organic carbon and nitrogen percentage, but also each time I take a sample, I'm going to record the species present and the abundance of each species, and that should change over time. So at the end, what I would do is plot a graph of species abundance compared to the carbon nitrogen ratio over time. Okay, and then comparing that between the different compost heaps should tell me if the carbon-nitrogen ratio is having an impact on the succession. That was question 9.